Hi everyone, and welcome to the Mat 211 review of Matrix, Inversion, and Determinants. My name's Julia, and I work for the tutoring centers at ASU. So today's problem says, are the following matrices an inverse pair? And we have this matrix A and this matrix B. So first of all, what does being an inverse pair mean? So if we have what are called matrix multiplicative inverses, that means that, say we have some matrix A. If matrix A to the -1, which would be a proposed inverse matrix, this -1 is a common way of denoting inverse matrices. If we have that A times A inverse equals A inverse times A equals the identity matrix, then the A and the inverse A are inverse pairs, meaning they're multiplicative inverses of each other. So it's important to note that this really only works for square matrices. So like, for instance, our A and our B here are both 3 by 3 matrices. It doesn't usually work if you have other dimensions because those don't have inverses. So in order to test whether or not our A and our B are an inverse pair, we want to test whether or not this relationship holds up. So instead of A times inverse A, we have A times B equals B times A equals I. If this is true, then our A and B are an inverse pair. So let's start by testing A times B. We'll erase these. Make some space. There we go. So our A is 3, 1, 0, 2, 1, 4, and 1, 0, 0. And our B is 0, 0, 1, 1, 0, -3, and 1, -1 quarter, 1 quarter, and 1 quarter again. All right, so let's go through and multiply this to see what we get. Well, for our first row, first column, we're going to have 3 times 0, that's 0, plus 2 times 0, oops, 2 times 0, wrong 0. But that's also equal to 0, plus 1 times 1, which equals 1, plus 1. Next, we're going to have 3 times 1, which is 3, plus 2 times 0, 0, plus 1 times -3, which is, so minus 3. And we can keep going along in this fashion. For our first row, third column, we're going to have -3 over 4 plus 2 over 4 plus 1 quarter. And then if we move into our second row, we have 0 plus 0 plus 0 for the first column, 1 plus 0 plus 0 for our second column, and -1 quarter plus 1 quarter plus 0 for our third column. And then in our third row, we have 0 plus 0 plus 0, and then another 0 plus 0 plus 0. And lastly, 0 plus 1 plus 0. So if we go through and sum these all up, we find that we indeed do have the identity matrix. So we have 1, 0, 0, 0, 1, 0, and 0, 0, 1, which is what we're looking for. And note that this identity matrix is the same size as both our A and B. that will always be the case. So it is also a 3 by 3 matrix. So let's go ahead and write up here, A times B equals identity. Check that. Now we want to check B times A. What does that equal? So let's go through. We'll move through this second one a little faster once we write it down. First, make some space. There we go. So for B times A, we have, again, 0, 0, 1, 1, 0, negative 3, negative 1/4, 1/4, and 1/4 times 3, 1, 0, 2, 1, 4, and 1, 0, 0 for the last column. Again, if we write out our multiplication here, we get 0 times 3, that's 0. 1 times 1 plus 1, and negative 1/4 times 0. That's just 0. And if we keep moving through this, our next column here is going to be 0 plus 1 minus 1. Our third column of our first row is 0 plus 0 plus 0. So 0 times 1, 1 times 0, and negative 1/4 times 0. Moving on to our second row, we end up with 0 plus 0 plus 0, 0 plus 0 plus 1, and another 0 plus 0 plus 0. For our last row, we have first we have 1 times 3, 3 minus 3, and then 1/4 times 0, so plus 0. And then we have 2 minus 3 plus 1, so that's going to be this row times this column. And lastly, we have 1 plus 0 plus 0, and that's this row times this column. So again, if we go through and sum this, we find that we have our identity matrix. So we can say that B times A also equals the identity matrix. So since we have A times B equals B times A equals the identity matrix, since that is true, we know that A and B are an inverse pair. So let's write that over here. A and B are an inverse pair. And that is our solution. Great. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support services at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for specific tutoring services for a course, such as a math course or chem course or whatever it might be, you can go to the Tutor search tool, which you can find on our main webpage or by going to this full link here. And that will allow you to search what we have for your course. Thank you so much and have a great rest of your day.